All right. So sure you get this jotted down. Oh. Always important when we're talking about trig functions to keep in mind pi, because in calculus, all of our trig functions we measure in radians, not in degrees, unless a problem specifically says that you're measuring in degrees. All right, let's take a look at the function sine of x. And we've talked a little bit about derivatives and kind of the tangent line idea. And if I look at, this point right here, what would the slope of the tangent line be right there? Would you guess? At that maximum value. We know, right? We know that it's positive here because it's an increasing function, and it's negative here because it's a decreasing function. So what does it have to be? Zero, right? Okay, so we can be pretty confident that the derivative here is 0. That is terrible. And the derivative down here at the bottom? 0. So if we look at those, and as I said, we know it's, and looks like over here we've got another 0. It's going to be positive, and then it starts to decrease, so it's negative, and then positive. What does that blue graph kind of look like? What function? Cosine. All right. So that would be a pretty good guess. So it would appear that maybe the derivative of sine is cosine. And because we're mathematicians, we're going to look at that and say, we don't care what it looks like. We want to know what it actually is. So we're guessing cosine. We want some proof. So if f of x is equal to sine of x, we're going to find f prime using our definition of a derivative. And I'm going to choose to use the limit as h approaches 0. Instead of a plus h, I'm going to use x plus h. Feel like the live stream of CNN, if you watch it on TV, it's about 5 seconds ahead of the live stream. That's kind of what's happening here. All right, so I am going to work on the right-hand side of this equation. So sine of x plus h, that's one of our great trig identities. If we have the sum of two angles, we get sine, I should say, if we have the sine of the sum of two angles, sine of the first, cosine of the second, plus cosine of the first, sine of the second.
Where did cosine come from?
It's actually in the definition of the sum of the sine of the sum of two angles. So because we have sine of x plus h, we can, instead of doing the sum of those two angles, we can take the sine of the first one times the cosine of the second, and then the cosine of the first times the sine of the second. You can trust me on that one?
Yeah.
Sure, okay. What's that?
Is that the product rule?
It's not the product. We haven't done anything with derivatives yet on this problem. So it's just an identity that you should have seen in trig at some point. It's also in the, so one great reference is that great inside front cover of your textbook. And there are all sorts of trig identities in this last column. Actually, it's almost this whole page is devoted to trig. All right. So I'm going to do some rearranging. And what I'm going to do is take this minus sine x and move it next to the other term that has a sine of x in it. See if that makes a difference here. Nope, really not. Okay. Excuse me. Anytime we have a fraction with addition or subtraction in the numerator, we can break that fraction apart into the sum or difference of fractions with the same denominator. So I'm going to take this and make two fractions. I'm going to make one with sine x cosine h minus sine x over h plus cosine x sine h over h. All right. Then, so I don't confuse myself, I'm going to write this as the limit of this fraction plus the limit of this fraction. Just again, so that it's clear to me and I don't need the parentheses anymore. All right. I can tell you're just all glued. You can't wait to see what comes next. So next, in this first fraction, I'm going to factor out a sine of x in the numerator. Now, this first fraction, I can factor out anything. I can take anything that doesn't have an h in it and move it outside of the limit. So the sine x, doesn't matter what happens to h, sine x is just going to be sine x. And likewise, in the second fraction, the cosine x can go out front.
How did you get sine x by itself?
Give me 1 minute. The sine x, is that what you,
Yeah.
okay.
Just show by itself.
So I went from this step right here where I have sine x cosine h minus sine x, and I just factored out the sine x.
Yeah.
Okay. And now because it's not affected by h, it doesn't matter what happens to h, sine x is just going to be sine x. Right? Because it doesn't have an h in it.
Yeah.
Okay. So that limit doesn't affect sine x. So I can take it outside of the limit then. All right. Now, let's deal with those limits. So there's nothing algebraically that I can do to calculate cosine h minus 1 over h and get so to cancel out the h's. And if I plugged in 0, I get cosine of 0 minus 1. Well, cosine of 0 is 1. I'd have 1 minus 1 over 0. And on the sine of h over h, I would have 0 over 0. And we know that that's not good. So what we're going to do is we're going to take a look at the graph or a table of values for cosine h minus 1 over h. See what happens as we get close to 0. So I am going to, there it is. I am going to graph cosine h. Actually, I'm going to do cosine of x because, my calculator isn't smart enough to know that it could use h. Divided by x, again, instead of h. And I'm really concerned about what happens as I get close to a value of 0. All right, so I'm going to zoom trig. What value does it appear that we're approaching as we get closer and closer to 0? Looks like 0. And if we looked at a table of values, we could see we can get as close to 0 as we want just by taking values of x, in this case, close to 0. So this part come on, there we go. There, all right, that part's 0. And what is sine x times 0? 0, okay, good. Is this thing on? All right, 0. All right, so now let's take a look at what happens to sine h divided by h. What's that?
So I'm gonna go out on a limb here and say 0.
You're going to say, is anyone else want to go out on a limb and make a guess?
Stick with what Tate's got.
Okay. Your limb just broke and your collarbone got fractured. I don't know. Oh. All right. So in this case, sine of h over h as h approaches 0 approaches a value of 1. So this part goes to 1, which, if we think back to what we thought we would get when we took our derivative, should make sense, right? Because this is going to be 0. We're going to have cosine times 1, which is just cosine. try this one more time. So there's the derivative. All right. We only have 5 other trig functions to calculate, right? We did derivative of sine. Yeah, we're not going to do all 5. Here are the other derivatives of the trig functions. Yes, it is expected that you memorize these. So the derivative of cosine is negative sine of x. The derivative of tangent is secant squared. The derivative of cotangent is negative cosecant squared. The derivative of cosecant is negative cosecant cotangent. And the derivative of secant is secant tangent. So a couple of things that might make this easier to remember. All of the functions that are co-functions, cosine, cotangent, cosecant, when I take the derivative, I get a negative sign. All of the ones that aren't co-functions, I don't get a negative sign with it. To prove that cosine x is, the derivative of cosine x is negative sine x, you'd have to do something similar to what we did with the sine function. I wouldn't ask you to do that, okay? On the AP exam, you wouldn't have to do that. All of the other functions, you can use quotient rule to find the derivative. We'll actually do one just so you can see it, and it takes about a third the time as it took to get the derivative of sine x. All right, so differentiate, find the derivative of y equals x squared times sine x. So what operation is working on that x squared and the sine x? Product rule, excellent. So product rule, take that first function, I always leave that one alone, times the derivative of the second function. The derivative of sine of x? Cosine of x. Plus, take the second function times the derivative of the first, and the derivative of x squared. So one of the things that students forget, or I shouldn't say forget, neglect, is to remember that there's still a product rule out there, there's still a quotient rule out there, and we need to abide by those rules as well, even when we have trig functions. All right. What is the 27th derivative of cosine x?
Make a guess.
What's that?
I said, I don't know how I'm supposed to do it, so I'll make a guess.
Make a guess.
Negative sine x.
Let's see how we do with that guess. What is the first derivative of cosine? Negative sine x. What is the second derivative? Or the derivative of negative sine x? Negative, and then the derivative of sine is cosine x. All right, what's the derivative of negative cosine x? Sine x. And we're at the fourth derivative. What's the derivative of sine x? Cosine x. And look at that, then we're back to where we started. So that's 4, but that would also be then the 8th derivative would be here, and the 12th, and the 16th, and the 20th, and the 24th, 25th, 26th, the 27th derivative would be exactly the same as the third derivative. That's one of the nice things about sine and cosine. They cycle through. All right, last little bit here. Prove that the derivative of tangent x is secant squared of x. No, we're not going to use the definition of a derivative. We're instead going to look at how tangent x, another way of writing tangent x. And tangent x is the same as sine x over cosine x. Easy for me to write. So if I take the derivative, I can use the quotient rule. And the quotient rule says, let's take the denominator times the derivative of the numerator. And what is the derivative of sine? Cosine. There we go. Minus the numerator times the derivative of the denominator. Derivative of cosine is negative sine. That's where the negative comes in. All over the denominator squared. All right, in the numerator, cosine times cosine. There you go. You'll often see that written this way instead of in parentheses with the square on the cosine. And then I have a minus and a negative in here. So I can make that plus. Sin x times sin x. Yep. Ugh. And what is cosine squared plus sine squared? One, yep, one. It's another trig identity. 1 over cosine is secant, so this has to be equal to secant squared. Much better than doing the limit as h approaches 0. Right? So you will have one in your homework that says, show or prove that the derivative of something is something. This is the way to do that, because it's not going to be show that the derivative of cosine is negative sine. It'll be one of the other trig functions. And then a couple, like 1 through 8 and number 13 are just straight, find the derivative. I think 17 is the one where you're showing that the derivative of a certain trig function is what it is. And then 19 and 21 are both finding the equation of a tangent line.